Welcome back. In last tutorial we imported KayKit animations. This time we will focus on character scene, especially mesh import and a script to take advantage of modularity. For this tutorial we will use character pack skeletons, so we can also see how to use blend shape facial expressions in Godot. First of all, we need to import the original files from the character kit. We can move the GLB files in Godot and open them. Like last time, we need to work on the original file, so click on Open anyway. Select the mesh instance for each body part, and in the inspector, click on Mesh Property and save. Let's pay attention to the name. In this example, we will use the following format: asset name underscore character type underscore body part, and if necessary, we can also add underscore broken as variant. We need to repeat this for all body parts of all characters we want to support and create a folder with all the parts. We can repeat this also with accessories like hats and capes. In previous tutorial we used just upper skull mesh instance, but this time we will see how to create a separate head scene to replace that simple mesh with a full head. First of all, in one of the imported GLB characters we add a new spatial node and move head and all of its parts as children of the new node. Then we right click and save branch as scene to create a head scene. The first thing we need to do is resetting the transform in upper skull mesh instance so that it is in the center of the scene. If we check this particular mesh instance, we can see that Inspector has an extra section for blend shapes. It is similar to the one we can find if we import the file in Blender, but we need to be careful as in Godot blend shapes have a minimum value of -1 instead of 0, so if we mess too much with values we could get undesired results. We could also move the jaw, but we need to define another pivoting point, so let's rearrange the scene tree. Since we have a new parent, we don't need all elements to be children of skull bone, and we move them. We add a new position 3D node and we place it at the right pivot point of the jaw. We make jaw its children and we rename it jaw joint. The last touch is adding a new special node for accessory with two mesh instance children. In each one of them we can load add accessories like Archer's Hood. We can set it invisible for now. Now we can save the scene and add a script to manage animations and meshes. We define an enum with character types. We also keep track of the asset name for future developments, in this case skeleton with the letter SK. Then we add a few export vars for type, where we use our enum as type, a broken bool export, and float values for anger, happiness, and mouth. Please note that in export we define the range of value. This will help limiting the range of blend shapes. All of this will have a setter function introduced by setGet, and let's not forget tool keyword on top of the script. Let's check the setters. Anger and happiness setter work the same way. They store the new value as is and then use it to set the blend property. Since we use tool, we can immediately test them in 3D view. If there's any problem, first try to save and close and then reload the scene. Mouth is very similar, but we need to map the value to an angle. I made this in a very empirical way. You can make more precise calculation and use a wider range. In this case, the opening of mouth is limited to avoid conflicts with lower accessories. The next export vars are references to all mesh instances in the scene: skull, jaw, and accessories. Then we have a parts array that we initialize in a ready function. Here we map all mesh instances with a string with the part name and then we call updateLooks function. This function simply checks the value of broken and type vars and composes a file name string to load the necessary mesh instances from our parts folder, and also sets accessory visibility according to character type. That's why it is very important to use a standard for part paths. We call updateLooks also in type and broken setters, so we can preview the looks in 3D view. Also, please note that almost every mesh in the package is already okay, but in some cases it may be necessary to edit the tile in Blender to have the same offsets in every part and accessory. Once we are done with the head, we move back to the whole character where we can repeat the same logic. Please note that in the script for the body, I duplicated the type enum. Ideally, we should share them in a global script. In this case, the update looks also sets the head type and broken options, and then it creates paths for all different paths. Please note that in this case we used an iteration because it's easier to manage body parts. We can test it using this as tool script. As you can see, I stick to suggested combinations of the assets pack. And we are done. Our character scene is ready for the next stage, that will be a small controller that we will use for both player and enemies. I hope you like this tutorial. If you have any comments, please write them below. See you next time.